Good evening, students. Today let us solve some more problems on differentiation. Let's look at this question. Let f of x equal to mod cos x, then f is everywhere differentiable, f is everywhere continuous but not differentiable at x equal to n pi, where n belongs to z. F is everywhere continuous but not differentiable at x equal to 2n plus 1 into pi by 2, and none of this. So for this, let's have a look at the graph of mod cos x. Before I draw the graph of mod cos x, I'll explain how to draw the graph of modulus of f of x when you know what is f of x. For example, let me draw the graph of y is equal to x. Y is equal to x is a straight line passing through origin, making an angle of 45 degree with the x axis, right? This is the graph of y is equal to x. Okay. Now, instead of y is equal to x, if I want y is equal to mod x, what should I do? So, mod x is a well known curve, you know, but now I will explain one idea how you can draw it with the help of the given function. This is the graph of y equal to x. If you want to draw the graph of y is equal to mod x, what you need to do is, you look at the portion of the curve which lies below x axis. So, this is the portion of the curve, that is before 0, the portion of the curve lies below x axis. Whatever the portion that lies below x axis, you take its image with respect to x axis. You draw the image of this with respect to x axis. Image of this with respect to x axis will be here. This will be the image of this portion with respect to x axis. Then remove this. That's it. This is the graph of mod x, which is very well known to you. Now look at the graph of sin x. This is the graph of sin x, right? Now, if you want to draw the graph of modulus of sin x, I want to draw the graph of modulus of sin x, what we need to do is, take the portion of the curve that lies below x axis. See here, from minus pi to 0, here pi to 2 pi, then here 3 pi to 4 pi, etc. Take the portion of the curve which lies below x axis, take its image with respect to x axis. So, take the image of this portion with respect to x axis. So, that will come here. Observe, this portion looks like the image of this. The x axis will act as a mirror, and take the image of this portion. Okay, image of this portion. Right. This is the graph of mod sin x. Did you understand? Now, let us have a look at the graph of mod cos x. For that, first I will draw the graph of cos x, then we will look at mod cos x. Cos x. This is the graph of cos x, right? Now, we will draw the graph of mod cos x. Mod cos x. It's like this. This is 0, pi by 2, pi, 3 pi by 2, 2 pi, etc. Right? Take the image of this with respect to x axis. Take the image of the portion of the curve that lies below x axis with respect to x axis. This is the graph of mod cos x. Okay? So now let us look at this curve, this problem. We want to test the continuity and differentiability of this function. Look at this curve. Look at this is the curve. This is the graph of mod cos x. Look at this. Is it continuous everywhere? Do you see any break at any point? Actually, there is no break. Though in my diagram that looks like there is a break. So this is the graph of mod cos x. There is no break anywhere. Hence, this function is continuous everywhere. And is it differentiable everywhere? For that, we need to look at by looking at the graph, how we can test whether a function is differentiable or not, that is, you look at the point where there is a sharp edge. Observe, is there any sharp edge for this function at any point? So, as we can see, there is a sharp edge at pi by 2, there is a sharp edge at 3 pi by 2, there is a sharp edge at 5 pi by 2, and on this side minus pi by 2, minus 3 pi by 2, etc. We observe that at all odd multiples of pi by 2, there is a sharp edge. Okay. So, at all odd multiples of pi by 2 there is a sharp edge, that means the function is not differentiable at all odd multiples of pi by 2. Odd multiples of pi by 2 can also be written as 2n plus 1 into pi by 2. 2n plus 1 into pi by 2. So, the function is not differentiable at x equal to 2n plus 1 into pi by 2, where n is an integer, n belongs to z, and it is continuous everywhere. So, third option is the correct answer. Now, if I replace that cos x with sin x, if I think of f of x equal to mod sin x and keeping the same options as it is, then what will be your answer? You just observe here, this is 0, pi, 2 pi, 3 pi, 4 pi, etc. And on this side minus pi, minus 2 pi, etc. So, what happens to mod sin x? Is it continuous everywhere? Yes, mod sin x is continuous everywhere. And where it is not differentiable? It is not differentiable at 0, pi, 2 pi, 3 pi, 4 pi, or minus pi, minus 2 pi, minus 3 pi, etc., which can be written as x equal to n pi. So, the function f of x equal to mod sin x is not differentiable at x equal to n pi, where n is an integer, and it is continuous everywhere, not differentiable at all multiples of pi. Okay. So, then if you replace cos x with sin x, then second option will be the answer. That same question you will see after some time. Okay. So, if it is mod cos x, as of now, third option is the answer. If I replace cos x with sin x, then second option would be the answer. Okay. Look at question number 60. Differential coefficient of secant tan inverse x is differential coefficient. Differential coefficient is another word for derivative. That's all. So, we are asked to find the derivative of secant tan inverse x with respect to x. Okay. So, I will take it as secant tan inverse x. Secant tan inverse x. Okay. So, I will make a substitution here, put tan inverse x equal to theta, then tan theta is equal to x. Draw a right angle triangle. Tan theta is equal to x. Tan theta is defined as opposite by adjacent. So, x by 1. If this is x, this is 1, then the hypotenuse would be root of 1 plus x square, right? Root of x square plus 1, or 1 plus x square. So, from this you write down what is secant theta. Secant theta is defined as hypotenuse divided by adjacent, that is root of 1 plus x square by 1, which is root 1 plus x square. Given problem is secant theta. I have taken tan inverse x as theta. So, from this I can write y is equal to secant theta, that means y is equal to root of 1 plus x square. Now, the problem is just to differentiate this, that is all. Derivative of this is 1 by 2 root of 1 plus x square into 2x. 2 gets cancelled. So, the answer is x divided by root of 1 plus x square, which is the first option. Then 63rd question. If y is equal to root of sin x plus y, then dy by dx is equal to. So, y is equal to root of sin x plus y. You have seen this problem, such problems already. So, it is of the form y is equal to root of f of x plus root of f of x plus root of f of x, etc. So, in such cases, what is y dash? Y dash is equal to f dash of x divided by 2y minus 1. That formula, you know, you can use that formula. Here f of x is sin x, so f dash of x is cos x, hence the answer is cos x by 2y minus 1. If you know that formula, if you identify that this problem is of this form, then you can directly write. In case if you do not know it, then also it is not a big deal, you can still solve this. You have y is equal to root of sin x plus y, right? Square this equation. When I square this, I am going to get y square is equal to sin x plus y. Now, you differentiate this, we get 2y dash is equal to cos x plus y dash. So, y dash, if I take common, y dash into 2y minus 1 is equal to cos x, which means y dash is equal to cos x by 2y minus 1, first option. 64. If y is equal to secant x e power x, then dy by dx at x equal to 0 is. You differentiate this with respect to x, dy by dx is equal to derivative of secant x is secant x tan x. So, you get secant x e power x into tan x e power x into the derivative of x e power x, that is x e power x x into derivative of e power x, which is e power x, plus e power x into derivative of x, which is 1. We are asked to find dy by dx at x equal to 0. Put x equal to 0 here, secant 0 is 1, tan 0 is 0 into anything that is 0 only. So the answer is 0, right? 0, which is again the first option. 66 now. If y is equal to 1 plus x into 1 plus x square into 1 plus x power 4, then dy by dx at x equal to 1 is. So a fairly simple problem. Y equal to 1 plus x into 1 plus x square into 1 plus x power 4. Y dash is equal to, use product rule, 1 plus x into 1 plus x square into derivative of 1 plus x power 4 is 4x cube plus 1 plus x into 1 plus x power 4 into the derivative of 1 plus x square, which is 2x, plus 1 plus x square into 1 plus x power 4 into the derivative of 1 plus x, which is 1. We want a derivative y dash at which point at x equal to 1. Put x equal to 1 here, 1 plus 1, that is 2, here 2, here 4, plus 2 into 2 into 2, plus 2 into 2. That will give you 4 into 4, 16, plus 8, plus 4, sum is 28. 28, which is the second option. Then 68th question. If f of x equal to mod sin x, then f is everywhere differentiable, f is everywhere continuous but not differentiable at x equal to n pi, n belongs to z. F is everywhere continuous but not differentiable at odd multiples of pi by 2, and it's not none of this, it should be none of this. Okay. Anyway, now already I have explained this in earlier while explaining f of x equal to mod cos x. Here f of x equal to mod sin x. This function is continuous everywhere and not differentiable at all multiples of pi at x equal to n pi, which means second option is the correct answer. Then 69th question. If the function f of x is defined by f of x equal to x power 100 by 100 plus x power 99 by 99 etc. till x square by 2 plus x plus 1, then f dash of 0 is equal to, f of x is equal to, right, what is f of x? X power 100 by 100 plus x power 99 by 99 plus x power 98 by 98 and so on till x square by 2 plus x plus 1. This is f of x. Now f dash of x. If I differentiate this, derivative of x power 100 is 100 into x power 99. There 100 gets cancelled, so x power 99. Derivative of x power 99 is x 99 into x power 98. So 99 gets cancelled, x power 98 and so on. Derivative of x square is 2x, 2 gets cancelled, x. Derivative of x is 1. This is f dash of x. I want f dash of 0. Put x equal to 0, last term will be 1, remaining all will be 0. So 1 is the answer, which is the third option. 71. If x is equal to a cos cube theta and y is equal to a sin cube theta, then 1 plus dy by dx whole square is equal to, x is equal to a cos cube theta, y is equal to a sin cube theta. We want a dy by dx, that's equal to dy by d theta divided by dx by d theta. dy by d theta is 3a sin square theta cos theta divided by dx by d theta is 3a cos square theta into minus sin theta. That's equal to 3a gets cancelled, sin theta gets cancelled, cos theta gets cancelled. You are left with minus tan theta. Okay, this is dy by dx. We want 1 plus dy by dx whole square, that's equal to 1 plus minus tan theta whole square, which is tan square theta. 1 plus tan square theta is equal to secant square theta, which is the first option. Then 74th question. If tan inverse of x square plus y square is equal to alpha, then what is dy by dx? Given tan inverse of x square plus y square is equal to alpha. From this we can write that x square plus y square equal to tan alpha. x square plus y square equal to tan alpha, differentiate this 2x plus 2y into y dash is equal to 0. So that means y dash is equal to minus x by y, minus x by y, minus 2x by 2y, which is minus x by y, first option. 75. If x equal to e power sine inverse of t square minus 1 and y is equal to e power secant inverse of 1 by t square minus 1, then dy by dx is equal to, x is defined as e power sine inverse of t square minus 1 and y is e power secant inverse of 1 by t square minus 1. Okay. So x equal to e power sine inverse of t square minus 1, y is equal to e power, the secant inverse 1 by t square minus 1 can also be written as cos inverse t square minus 1, right? Secant inverse 1 by x equal to cos inverse x. Now x is e power sine inverse t square minus 1, y is e power cos inverse of t square minus 1. I will multiply these two equations. See, here x and y are expressed in terms of the parameter t. So you can go for parametric differentiation, that is dy by dx is equal to dy by dt divided by dx by dt. That obviously you can do it. But here I can observe something, that is sine inverse t square minus 1 here and cos inverse t square minus 1. So if I add those powers, sine inverse t square minus 1 plus cos inverse t square minus 1, it will be pi by 2. So that differentiation would be easy. That's the reason. I want to add the power means I have to multiply these two, right? So I'll multiply these two equations, x into y, that's equal to e power sine inverse of t square minus 1 into e power cos inverse of t square minus 1. That's equal to e power sine inverse t square minus 1 into e power cos inverse t square minus 1. You will get e power x into e power y is e power x plus y. This will be e power pi by 2. xy is equal to e power pi by 2. Now you differentiate it. X into y dash plus y is equal to 0. E power pi by 2 is a constant. So y dash is equal to minus y by x, which is the second option. Then if tan y is equal to 2t by 1 minus t square, sin x is equal to 2t by 1 plus t square, then dy by dx is equal to tan y is equal to 2t by 1 minus t square. I can write y is equal to tan inverse of 2t by 1 minus t square. Sin x is equal to 2t by 1 plus t square. From here we can write x is equal to sin inverse of 2t by 1 plus t square. Y is tan inverse 2t by 1 minus t square. Tan inverse 2t by 1 minus t square is nothing but 2 tan inverse t. And sin inverse of 2t by 1 plus t square is also equal to 2 tan inverse t. Now both are equal to 2 tan inverse t. We are asked to find dy by dx. That means differentiate y with respect to x. Here both y and x are one and the same. Therefore, the derivative of y with respect to x will be equal to 1. Okay? Or if you want to use parametric form of differentiation, you are allowed to do it. Dy by dx is equal to dy by dt divided by dx by dt. Here you get 2 by 1 plus t square. There also you get 2 by 1 plus t square. Cancel them, get the answer as 1. 1, fourth option. 79th question. If y is equal to log x, then dy by dx, then d square y by dx square is equal to. If y is log x, then we are asked to find the second derivative of y with respect to x. Okay. So y is equal to log x. Differentiate it once. Dy by dx is equal to 1 by log x into the derivative of log x, which is 1 by x. So this is 1 by x log x. So now d square y by dx square is equal to, it's of the form 1 by x. Derivative of 1 by x is minus 1 by x square. So here you get minus 1 by x log x whole square. minus 1 by x log x whole square into now the derivative of x log x. Derivative of x log x is x into derivative of log x, which is 1 by x, plus log x into derivative of x, which is 1. Here x gets cancelled. So, minus of 1 plus log x divided by x log x whole square. That is the answer. Minus of 1 plus log x by x log x whole square. This is not. This one is the right answer. Second option. Minus of 1 plus log x divided by x log x whole square. Then 80th question. If y is equal to f of x, g of x, h of x, determinant of f of x, g of x, h of x, L, M, N, A, B, C, then what is dy by dx? Okay. See here, y is equal to, we have this determinant of f of x, g of x, h of x, L, M, N, A, B, C. Okay. Then what is dy by dx they are asking. How to differentiate a determinant, do you know? Yes. You differentiate one row at a time by keeping the other two rows fixed. Here in this particular problem, in this determinant, you observe that the second and third rows are constants. L, M, N and A, B, C are constants. The first row is f of x, g of x, h of x. So, while differentiating, we have to differentiate one row at a time, keeping the other two rows fixed. So, what I do, I will differentiate the first row, keep the second and third as it is, plus. Now, I will write another determinant where I have to differentiate the second row. The second row is a constant, so its derivative will be 0. Every element of that row is 0, means the value of that determinant would be 0. Okay, I will write one step here. dy by dx will be equal to, now differentiate the first row, f dash of x, g dash of x, h dash of x. Keeping second and third rows as it is, L, M, N, A, B, C, plus. Now you differentiate the second row by keeping first and second as it is, f of x, g of x, h of x. Second row consists of L, M, N, which are constants. So, when I differentiate them, we get 0, 0, 0. Keep third row as it is, plus. Now, write another determinant wherein you are differentiating the third row by keeping first and second as it is, f of x, g of x, h of x, L, M, N. Now, I will have to differentiate that third row, A, B, C, which are constants, so its derivative will be 0. Okay. Now, you look at the second determinant. Here the second row, every element of the second row is 0. So, the value of that determinant is 0. Similarly, here third row is 0. So, the value of this determinant is also 0. Therefore, what is dy by dx? That is equal to f dash of x, g dash of x, h dash of x, L, M, N, A, B, C. Okay? Which is the first option, f dash of x, g dash of x, h dash of x, L, M, N, A, B, C. But just to keep an eye on fourth option here, all the above is there. So, you have to be careful that whether second and third, that also you have to cross check whether they are also answers or not. So, clearly you know first option is the answer. What is the difference between first option and the second option? Of course, other than this is the first option, that is the second option. Anything else, any other difference is there? See, from this what I do is, I will interchange first and third row. When I interchange first and third row, what happens? If I interchange two rows, sign of the determinant changes. So, this will become minus A, B, C, L, M, N, f dash of x, g dash of x, h dash of x. Okay? After that, I will interchange first and second rows. I will interchange first and the second row. When I interchange two rows, then also sign changes. So, again it will be minus into minus plus. You will have L, M, N, A, B, C, f dash of x, g dash of x and h dash of x. So, what it suggests is that first option is same as second option. And what is the difference between first option and the third option? If I take the transpose of this, this is what I get. In a determinant, if we interchange rows with the columns, as we know, then there is no change in the value of the determinant. It is one of the properties which says that when the rows and the columns are interchanged in a determinant, then there is no change in the value of the determinant. So by using that property, you can see that these two are one and the same, which means first, second and third all are correct, and therefore fourth option is the right answer, all the above. 83rd. If cos y is equal to x into cos a plus y with cos a not equal to plus or minus 1, then dy by dx is equal to, okay, so they have given that cos y is equal to x into cos a plus y. We want to find out what is dy by dx. You just look at the options. None of the options contain x. All the options are in terms of y only. Okay. Now you might say, sir, it is in terms of a also. Yes, it is true, but a is a constant. I am talking about variables. Every option is in terms of y only. So they are not in terms of x. So instead of differentiating as it is, what we do is we will express x as a function of y. So from this equation I can write x is equal to cos y divided by cos of a plus y. Okay. So x as a function of y. Now I will differentiate this with respect to y, not with respect to x, with respect to y I will differentiate. That will give us dx by dy, and finally I will take its reciprocal. Okay. I have x here, I am differentiating this x with respect to y, which will give us dx by dy, and later at the end I will take its reciprocal, that will give you dy by dx, which is what we want, and that answer will obviously be in terms of y only. It will not be in terms of x, it will only be in terms of y. So with that reason I am writing x as a function of y and differentiating this with respect to y, differentiating with respect to y. Okay. On LHS we get dx by dy, on RHS cos square a plus y, I am using quotient rule here, cos a plus y into the derivative of cos y, which is minus sin y, minus cos y into the derivative of cos a plus y, which is minus sin a plus y. Now don't write into y dash, because you are not differentiating with respect to x, you are differentiating with respect to y. So this minus into minus will be plus. So here you have sin a plus y into cos y minus cos a plus y into sin y. It looks like sin a cos b minus cos a sin b. Sin a cos b minus cos a sin b is equal to sin of a minus b. Sin of a minus b means a plus y minus y divided by cos square a plus y. Y gets cancelled, so you have sin a divided by cos square a plus y. Sin a divided by cos square a plus y, which is the option. If you think first option is the right answer, you are wrong, because what you have done here is we have found out dx by dy, but the question is to find out dy by dx. So at the end what we should do? You should take its reciprocal. So when I take its reciprocal, I am going to get cos square a plus y divided by sin a. So its reciprocal is the answer. Okay, its reciprocal is here, cos square a plus y by sin a. That's what happens in CET. See here in CET, questions will be easy, as you can see, when compared to our earlier problems and the problems which I am solving today. You will see that these problems are much easier when compared to the earlier ones, because these are the problems which were asked in our earlier CET exams. So CET exams questions will be easy only, but the answers will be a little bit tricky. Little bit tricky in the sense that if you make one small mistake, so that is, say like this, if you make a small mistake, you will end up getting another answer, and invariably that answer will be present as one of the options. So they will give options in such a way that when you make one minute mistake, when you make a small mistake, you will end up getting an answer, and on most of the occasions that answer will be present in the options, and more so in the first option itself. Okay, so that is why you have to be a bit more careful. Okay, so dy by dx we have got cos square a plus y by sin a, which is the second option. Let's move to the next question now. 84. If f of x equal to mod of cos x minus sin x, then f dash of pi by 6 is. F of x is equal to modulus of cos x minus sin x. Mod of cos x minus sin x. Then what is f dash of pi by 6? Pi by 6. Okay, now we should see in the neighborhood of pi by 6 how this is defined. Is it defined as cos x minus sin x or sin x minus cos x? See, mod x minus a. How do you define mod x minus a? That's equal to x minus a if x is greater than or equal to a, and a minus x if x is less than a. Similarly here, it will be cos x minus x, or you think of this also, mod x is equal to x if x is greater than or equal to 0 and minus x if x is less than 0. So this will be equal to cos x minus sin x if cos x minus sin x is positive, and it will be minus of cos x minus sin x when cos x minus sin x is negative. Okay. So I will write it like this. This f of x, we can write it as cos x minus sin x if x is greater than or equal to 0, less than or equal to pi by 4. Between 0 and pi by 4, cos x is greater. See, between 0 to pi by 4, graph of cos x lies above the graph of sin x. This is pi by 2, this is pi by 4. So at 0, cos is greater than sin. At pi by 4, both are equal. At pi by 2, sin is greater than cos, because sin pi by 2 is 1 and cos pi by 2 is 0. From 0 to pi by 4, cos x is greater than, the graph of cos x lies above the graph of sin x. From 0 to pi by 4, cos x is greater than sin x. From pi by 4 to pi by 2, sin x is greater than cos x. Right? That you know. So I can write like this. So cos x minus sin x will be positive in this interval, because cos x lies above the graph of sin x. It will be positive in this interval. And after that, from pi by 4 to pi by 2, cos x minus sin x will be negative. So this will be minus of cos x minus sin x. In other words, I can write it as sin x minus cos x if x is greater than pi by 4. Greater than or equal to also you can write, because there at pi by 4 both will be equal. Both will be equal to 0. Cos pi by 4 is equal to 1 by root 2. Sin pi by 4 is also 1 by root 2. So their difference is 0. Less than or equal to pi by 2. Okay. So now we are asked to find out f dash of pi by 6. So here you see this is 0, this is pi by 4 and this is pi by 2. We are talking about pi by 6, which is 30 degrees. So pi by 6 is here. We are in the neighborhood of pi by 6. So you just zoom it. Okay. So in the neighborhood of pi by 6, should I take cos x minus sin x or should I take sin x minus cos x? Neighborhood of pi by 6 means clearly less than pi by 4. When it is less than pi by 4, what should I take? I should take cos x minus sin x. So in that interval, in the neighborhood of pi by 6, this f of x is written as cos x minus sin x. Then f dash of x is equal to minus sin x minus cos x. Then we want f dash of pi by 6. Put x equal to pi by 6. Minus sin pi by 6, that is minus 1 by 2. Minus cos pi by 6, which is root 3 by 2. Take minus as common, 1 plus root 3 divided by 2. Minus of 1 plus root 3 by 2, which is the first option. Okay. After that, 87th question. If step x represents the greatest integer function and f of x is equal to x minus step x minus cos x, then f of pi by 2 is. Step x, step x is not continuous at all integers, and obviously therefore not differentiable at all integers, but everywhere else it is continuous as well as differentiable. Now we are talking about f dash of pi by 2. Pi by 2 is not an integer. Pi, its value is 3.142, etc. Right? So divide by 2, which comes around 1.57. So there, it's not 1.57 is not an integer. Hence, it does exist. Okay. So in the neighborhood of pi by 2, that is in the neighborhood of 1.57, what happens to step x? Step x value, as you know, if x is between 1 and 2, step x is equal to 1. So, in the neighborhood of pi by 2, step x value is equal to 1. Hence, f of x can be written as x minus 1 minus cos x. Now, differentiate it. F dash of x is equal to 1 plus sin x. We want f dash of pi by 2, that's equal to 1 plus 1, which is equal to 2. Third option is the right answer. Okay. Look at 88th question. F of x is equal to sin inverse of 2 power x plus 1. 2 power x plus 1, I can write it as 2 into 2 power x divided by 1 plus 4 power x is there. 4 power x can be written as 2 power x whole square. This looks like sin inverse of 2x by 1 plus x square. Sin inverse of 2x by 1 plus x square equal to 2 tan inverse x. Therefore, this will become 2 tan inverse. In place of x, we have 2 power x. 2 tan inverse 2 power x. Now differentiate it. F dash of x equal to 2 into derivative of tan inverse x is 1 by 1 plus x square. So, here you get 1 by 1 plus 2 power x whole square into the derivative of 2 power x, which is 2 power x into log 2. This is f dash of x. Now, I want f dash of 0. Put x equal to 0. Put x equal to 0. 2 power 0 is 1. 1 plus 1 is 2. 2 gets cancelled. 2 power 0 is 1 into log 2. So, log 2 is the answer. That is the second option. 89th question. Okay, last question on this chapter. If x equal to a secant square theta, and y is equal to a tan square theta, then what is d square y by dx square? Okay, I can solve this by two methods. One is the actual method. Here the function x and y are expressed in terms of the third variable theta, parameter theta. So, parametric differentiation dy by d theta is equal to dy by dx is equal to dy by d theta divided by dx by d theta. So, dy by d theta is 2a tan theta into secant square theta divided by dx by d theta is 2a secant theta into secant theta tan theta. That's equal to 2a gets cancelled, tan theta gets cancelled, secant square theta also gets cancelled. 1 dy by dx is 1, we want d square y by dx square, which is equal to 0. Derivative of 1 is 0. Okay, this is one method. Another method is you have x equal to a secant square theta, y is equal to a tan square theta, right? I will write a secant square theta as 1 plus tan square theta. Secant square theta can be written as 1 plus tan square theta. So, x is equal to a plus a tan square theta. Take this a inside, a plus a tan square theta. What is a tan square theta? A tan square theta is nothing but y. So, x is equal to a plus y. Now, differentiate this with respect to x. We had 1 is equal to dy by dx, or dy by dx equal to 1. Therefore, d square y by dx square is equal to 0, 0. Third option. Okay. Students, with this we have come to the end of differentiation. So, you solve all the problems whatever that I have left in between, and if you have any doubts, you ask that in our WhatsApp group. It is observed that a lot of students are not watching our videos and not solving enough problems, because during the initial days when we started these online classes, many of the students were very active in the group. You used to ask so many questions, but now it is not the case. Okay, every day, in the WhatsApp group, if you check, you will see mainly the schedule and the 4 classes that we have given, and hardly any question is asked, which should not be the case, because we are not sure when the college will start. So, you have to ensure that you should stay focused, you have to ensure that you are in a good position to attend any of the exams, whether be it the PUC exams, CET, NEET or JEE mains. You should be very well prepared for it. Okay, so because there may not be much time left once the college starts, then for your exams there may not be much time. So we are not sure how long these online classes will go, but there is no other alternative. We have to live with it, whether you like it or not. That's not the question here. We have to live with it. Watch all these videos and solve all the problems. Whatever the doubts you have, you post your doubts, post your questions in our WhatsApp group, and our lecturers are very eager to solve those questions. Okay, thank you.